and I'm assuming this thing is doing something, but I do not know.
It's one of them.
Okay, perfect. So this is going to be interesting for a couple of different reasons. The biggest one being I'm sitting down, and I'm one of these people who is, I need to stand to talk. And the best way to shut me up is make me sit down. So this is going to be really entertaining. Anyhow, I'm Mahesh Paolini-Subramanya. I head up engineering for a company called Cielo 24, which it's long and complicated, but we essentially do derive media intelligence from videos, which basically translates to if you want your videos captioned, we can do that for you. If you want keywords, we can do that for you. If you want to do recognition, we can do that for you. You want to do anything to your videos, we can do that for you. We are, full service in that aspect. And I've been doing Erlang and Erlang related stuff for a long time at this point, a very, very long time, which is actually one of those things you'll find out I suspect if you do like a distribution chart of Erlang people versus Erlang, it's like you get a spike, people pick it up, they do something for about a year, and then they drop it, and that's the end of it, they never touch it. But if you go past about a year, it's like, what are you working on? Yeah, something in Erlang, and that's it. It's like 10 years down the road, they're still doing the same thing. And there's probably, that's a separate talk and it's a separate story, but the bottom line is it works out extremely well for you if you do that. Anyhow, there is a story about Erlang. This, however, is a story about the other part of Erlang, something called OTP, which I will maybe do. There we go. So first and foremost, and just as a quick recap here, how many people have actually, or how many people here actually know about Erlang or have used it before? Most people. Used it? Some? A little? A lot? Anybody? One? Wow, okay. Two, I guess, but yeah, I forgot about myself. Okay, so the Buddha nature of Erlang is fault tolerance. It begins and it ends with fault tolerance. It begins and ends with reliability. Everything else is kind of like, wow, you could do that with other stuff too. There's some advantages in Erlang. It's a functional programming language, which means it's by definition a wee bit terser than writing stuff in assembler, so you got that going for you. But if you take that out of the way, at the end of the day, the thing that sets it apart, that puts it off on one side and you say, yeah, I used Erlang for that and it was the best decision I ever made, it's when you're doing something involving reliability and fault tolerance. So, as a really quick recap, when we talk about fault tolerance, we talk about 6 very specific things. Concurrency, and by the way, when I'm talking about fault tolerance, I'm talking about a very specific definition of fault tolerance, almost an academic definition. Concurrency, that means you can do more than one thing at any given point in time. Why is that important? If you can only do one thing at a time, then if that one thing freezes, you're hosed. Not very fault tolerant. Fault detection. It froze. You need to know that it froze. Fault identification. What froze? Why did it freeze? Error encapsulation. Yeah, it froze. Don't let that virus go past the Caribbean, wherever. Code upgrade. Fix it. Stable storage. Oh shit, oh shit, oh shit, I can't fix it. Well, let's go back to the last place that we knew we were good and save game, basically. If you got these 6 things and you got these things pegged in your code, you're fault tolerant. Okay, not really, but that's whatever. We'll stick with that. But just keep that kind of in your head. That's kind of important. If you take those aspects and you kind of extend it out a wee bit, you end up with what I'll call like meta fault tolerance, or it's fault tolerance from one level higher. When you got fault-tolerant code or fault-tolerant systems, it's important that you can reason about the code that you have. You can look at the code and it makes sense to you. And it doesn't just make sense to you today because you wrote it today. 6 months from now, you look at the code and you don't go, dude, what the hell is this? I wrote this? Or, or somebody else wrote this, and you're like, you all know the drill. It's pretty horrible. You can, in fault-tolerant code, you can localize functionality. This is kind of the same as a combination of the error encapsulation, fault detection, fault identification. The point here is things are loosely coupled. Things can be updated or upgraded without infecting other things, so on and so forth. Basically localization. You can provide guarantees, which is also a very loose term for being able to reason about the code and about being able to localize functionality. It's essentially about being able to say anything from, I can guarantee that the messages, transactions will occur in order. Messages will get from component A to component B in order. When things get committed to the disk, they stay committed to the disk. You know, just guarantees. And maybe the loosest of all possible definitions, it simplifies development. If things are incredibly complicated to build, it's hard to make sure that they stay up. It just is. Rube Goldberg systems. Brief aside on that one, this is not always true. The nature is the best example of situations in which incredibly complex systems are incredibly stable. Malaria. Seriously, it's got this insane cycle of progression. And you think, just tweak this one little thing and it's, you can kill it. They haven't been able to do it thus far.
Can you qualify what you mean by reason about code? I come from dynamic typing community, so I know that my Haskell friends would say that reasoning about code is programs or proofs. So I don't think that's what you meant.
Well, it's not quite the code approach to existence or something, but it's more about I'd say at two different levels. At the simple level, it's actually being able to look at a piece of code and unequivocally know what that thing is supposed to do. That's a simple approach to existence. The higher level is where you start getting to the guarantees, which is this code says it does this and I can prove that it does this. In the world of Erlang, that's when you start getting into things like common tests and proper and a bunch of other things, which I'll get to in a moment.
When you use the phrase proof, are you in a sense saying it's a mathematical proof, or are you in a sense saying I have a 99% certainty that I will get what I expect?
Yes to both.
Okay.
Really, yes to both. In the purest sense of the word, if, for example, you have a one and done piece of code, I'm sending the Mars rover out to, that was smart, I was so certain I was going to keep this up. I'm going to send the Mars rover up there. It's one and done. We don't have a choice about this. It's got to go, it's got to work, it's got to stay up. In that one, you really better be able to prove absolutely you know what's going on. But otherwise, we're talking code coverage, we're talking test coverage, all those things that you'll be able to do. So that was your incredibly rapid take on why Erlang, even though I didn't say much anything about Erlang out there. That's kind of the point behind using Erlang, is you get everything that I described basically for free. The way you build systems so that they're fault tolerant is the default way you write code in Erlang. If you want to write crappy systems in Erlang, you absolutely can. You just have to work at it. And that's the important thing. That's a distinction. It's kind of, well, I'm not going to bash Java here, but we'll go with that. So let's talk about OTP. When people say Erlang, people actually mean Erlang OTP. And OTP theoretically stands for something called Open Telecom Platform. But I think theoretically it doesn't stand for that anymore. Now OTP stands for OTP. It's just, it's a thing. OTP is essentially the rest of Erlang that you should be using when you're writing stuff. And my buddy Jesper and I, a couple of years ago, came up with what we call the 5 stages of learning Erlang. And stage 1 is you learn Erlang and you're like, oh my God, this is the greatest thing in the world. Life is awesome. I'm going to write these great things. And most people just stop there. Exhibit A is Damien Katz with CouchDB. He wrote it in Erlang. And it was awesome. It's also like horrible code, but it was awesome. Stage 2 is you discover OTP, and you look at that and you go, holy shitballs, what was I doing before this? Why was I doing this? This is the truth and the way and the life and whatever. I should have been doing OTP from the beginning. And there's a reason for it, by the way. The thing is, OTP is in essence a whole bunch of behaviors, which I'll explain in a moment, that essentially give you the tools for writing those fault-tolerant systems that I'm talking about. When I say behaviors, think patterns. So Erlang, just basic Erlang, that's it's just a language. Yeah, it's got a whole bunch of concurrency-oriented primitives, spawn, link, monitor, trap, all of that fun stuff, trap exit. But at the end of the day, you could be writing that in pretty much any language. I mean, you could still do it in Erlang and it's easier, but Python, Lisp, whatever, you could write it. OTP adds two things. One, it adds a set of abstractions, essentially a set of battle-hardened, industrially reliable libraries, for lack of a better word, that abstract certain activities that you used in building fault-tolerant systems. So for example, when I mentioned concurrency, concurrency isn't just about being able to do more than one thing at a time. There's all these little subtle things that you need to know, like if there are two processes running, the processes need to know about each other. And if one process dies, the second process needs to know that the first one died. And it needs to know reliably that when I sent a message to process B, it got there, and it needs to be node invariant. I sent it on this machine, or it's on some other machine at a cluster somewhere else, it still got there. All of these things, which you could absolutely write by yourself, what the OTP team at Ericsson did is they essentially sat down and spent like months, years, writing these libraries which encapsulate all of this. So there's a thing called proclib, which is essentially a library that at the single most basic level, it's associated with spawning processes. But it does everything. It deals with every single one of those edge cases, even the ones that you don't think about, especially the ones you don't think about. There's a whole bunch of other things along those lines that are in these abstractions. You can ignore them completely for now. Above that, and this is the meat, there are these things called behaviors, which is what everybody sees when they think about abstraction, when they think about OTP. The behaviors are essentially a set of building blocks, think patterns for lack of a better word, canned patterns for lack of a better word, which allow you to actually build those fault-tolerant systems by assembling them and filling in the code. Think of them as templates that take care of all of this stuff for you. Gen servers, which are basically client-server systems, canned client-server mechanisms that you can use with processes, finite state machines, event handlers, supervision trees. Processes supervise other processes so that they can be restarted in case of transient errors, things like that. All of these just kind of show up for free as part of these building blocks. The really, really important thing about all of this is you could write in Erlang, you could write them using the abstractions. Don't do that, just use the behaviors. They just work. They're battle hardened. They really, really just work. Yes, you do find the occasional bug with them. And usually when you find a bug with one of these, it's like, okay, you demand, you found a bug. Seriously, it's like that. So, and it's increasingly harder. I mean, it's like, I remember we found, separate story, I won't go there. Yeah. Anyhow, the thing here is, when you're using OTP and you're using those behaviors, yes, you absolutely could go down one level, use the abstractions yourselves. People do that. So, for example, if I can get this back up again, maybe.
Might be the trajectory wants to see.
Maybe not. Let me see whether it'll do anything.
I think it's projected.
It thinks it's doing something.
Try and narrow.
Woo! And we're back. Right.
You know, there's a good call. Okay.
Yes.
So I can imagine, well, two questions. One, well, you're calling abstractions, it's really kind of like management.
Kinda. Think of it more as almost like Django is to Python if you're doing MVC frameworks. These are to building Erlang-based systems. It's like it builds all those high-level abstractions that you need in a general form with the minimum viable functionality necessary to provide that specific piece of that specific abstraction that you need. You need a client-server abstraction for each process. Yes, this gives you exactly that, no more, no less.
So it's like the automatical.
Exactly. The thing is,
Slightly different, that's when.
well, yeah, and that's kind of the whole point. If you really want to do something, if you want, in the end, if you want to do something completely different, rock on. However, if you just want more performance, which is unlikely, but some people do, when you do need that additional bit of performance, you can move down the food chain. So instead of using GenServer, which is the client-server abstraction, roll your own. It's not that hard. You can roll your own. The thing is, you need to be very, very, very clear about what you're getting and what you're giving up, because you will be giving something up. So and that's kind of the point, really. Don't go down the food chain. But a good example of this is, for those of you who have used Erlang at some level, essentially there's a web front end, for lack of a better word, called Cowboy, which is the de facto, almost like one of the three standard web front ends for Cowboy. I mean, for Erlang. A huge chunk of Cowboy is implemented using just the libraries. So instead of using the actual behaviors, it uses the libraries. It uses proclib. It uses sys. It uses gen. It just does stuff down at that level because Loic basically looked at the stuff and said, I don't need these. I don't need all these additional extra things. So just be aware of that. So let's make this a bit more concrete and look at a very specific, or start with a very specific one, which is GenServer. So GenServer is essentially all about state management. The heart of Erlang is processes. Everything in Erlang is basically a process. You could either deal with processes as they're very basic, it's a process and you just write all your code and you spawn the process and have the process do it, or you use this GenServer mechanism and it takes care of the communications, the state management, the startups, the shutdowns. It takes care of all of that for you, for free. Think of it as in a client-server environment, it is the server that you're dealing with, or it's the event loop. There's a bunch of different ways of thinking about it. It's all of them and none of them at the same time.
Can you restart your QuickTime?
Oh, did I forget that? Good point. And we're go. So maybe the most important part is the last line, which is when you're writing Erlang code, you will discover that something like 90 to 95% of all of your code that you're writing ends up in GenServers. If you're not using GenServers, you're either very, very, very special or you're doing it wrong. I'm betting on the doing it wrong side of things, but you could also be special. I'm not. So, yeah. So let's look at a specific example of a GenServer, the actual code therein. This is a very, very, very basic, in fact, this is about as absolutely basic as the template goes. And just to walk through the lines, to give you a bit of context on these things, first line, all it's saying is, hey, I'm just a file, my name is Erlang worker. And there's no particular reason behind this. There actually is, but you can ignore that. for this experiment. The behavior is gen server. That's very important. That's what tells the system, hey, this particular file is associated with the type of thing called a gen server. Ignore a bunch of the lines. The record here, state, broadly speaking, what I'm saying is, in general, in the system, this is the thing that I care about. This could be something as simple as 2 integers that I have in there. It could be something as complicated as a bunch of database accessors and something else. It could have records and maps and tuples and, you know, who knows what. It's where you carry the ongoing state of the process. An important thing to remember about gen servers and processes and fault tolerances, just assume that this thing is just going to crap out at any random point in time. So when you write your processes, usually the way it works is what you keep in your state is what you can afford to lose. So you think of your state as a cache. You write the contents of your state to some kind of persistence, and when you're done with it, you then respond to whoever called you saying, yep, I'm good, let's move on. That's a client-server thing. You get a request from a client, it hits the gen server, which is the server does a bunch of stuff, writes it to persistence, maybe, stores the information in the cache, maybe, and moves on. Maybe you're just reading stuff, just respond from the state. We're good. This line, start link, basically says when this process gets started up, this gen server gets started up, link it to the supervision tree. That's what the start link is. I could use start instead of start link. All that would mean is it would get started and be a free-floating process that I would need to keep track of the process ID. I would need somebody to tell me, oh, hey, I would need to monitor it, which is an Erlang term that basically says, if that process dies, let me know so I can restart it. But by doing a start link, I automatically get all of that. I get it for free. If it dies, it gets restarted for me. Life is good. This module, or this function, init, is the thing that gets called when the gen server gets initialized. The first line I just put in there, it's not necessary, but essentially what the process flag, trap exit, true, that line, what it means is if, for argument, let's pretend that this gen server spawned a bunch of its own gen servers. You have an entire process tree. One of the nice things in Erlang, or not so nice things, is whenever a process crashes, it tells everybody up the food chain, hey, I died. It sends an exit message up the food chain. The exit message will immediately kill the process right immediately up the food chain from it. If you don't want it to die, you need to put this line in there. Classic beginner's mistake is they put this in, they don't have that line in there, they start their processes, they build this elaborate supervision tree. The first time something goes wrong, everything just craps out, boom. They're kind of sitting there going, why did that happen? By the way, the point isn't always put that line in there. If it crapped out, it probably crapped out for a reason, and that's why everything's dying. So fix it.
What do you mean by a food chain? You mean a call stack or?
No, process stack.
Oh.
So you got a process, it spawns a second.
Okay.
So I'll get to supervisors in a moment, but say this gen server, supposing in init, I had another line that said this. This line, what would happen is, as part of the startup of this gen server, it would start up a second gen server, which you would look for in a file called some other module.url for the information about that, and it would link that to this one. Because maybe this is my, this is bad code, but maybe this is my master process, and there's a bunch of secondary processes, one of which reads a database, one of which initializes a web server, one of which does something else. Each one of those runs in its own little gen server. So think of a gen server as like the smallest atomic unit of action that I can have in its own file as its own unique piece of functionality.
Now, when you spawn a process, does that process stay alive until the spawn process dies?
Yep.
And how do it does? Okay. So
It's
no
just
problem.
up for life.
Okay.
Unless I have a timer in there saying after some amount of time, kill yourself. And I'll get to that in a bit.
At what point would you bring dialyzer into the fold here, and like how would you type something reason about like your?
So, if you hold that thought. So, Erlang uses dynamic typing. And there's a long, complicated thing about there's been an attempt to get static typing into Erlang for infinity years, and it's never happened, largely because of the distributed nature of Erlang, and you don't know what is actually dealing with the messages that you're sending to other nodes. And static typing gets to be very entertaining in those kind of situations. Yeah. Dialyzer is a success typing mechanism. Think of it like an inverse Bloom filter. Basically what it's doing is that it'll go through your code and it'll say, if it says, I found a problem, this particular thing is going to return a type that is incorrect based upon what it's supposed to be doing. If it says there's a problem, you have a problem. But it won't guarantee you that that it will find the problems.
Are you talking about lines 13 and 14 with the integers here, or is that something separate?
Oh no, that's separate. This is just in general. There's a thing called Dialyzer which you can run as a separate tool, and which I probably could and will, and will do something, and who the hell knows what happens here.
If it's dynamically typed, why did you put integer to the right of those two?
To help with the success typing. Those are hints that I can give Dialyzer. They're strictly speaking not necessary, but by giving it those hints, it winnows the success typing tree so that it can go in and say, I'm just going to ignore a bunch of the other things out here because it's supposed to be an integer. Yeah. But yeah, the downside to Dialyzer, it also takes infinity to start up.
Do you recommend using dialyzer?
Yes. If you're not using Dialyzer, you should be. Yeah, absolutely, unquestionably, always. Now that I said that, let me take a step back. If it's production code, yes. If it's, oh, I'm just messing around with this stuff and I'm playing with it to see what happens, it doesn't particularly matter. What I will say, however, is you'll find weird and interesting things that you didn't know you had in there. It's like, oh wow, here's a nice edge case, which is the point. That's what you want to do. So to kind of blast through some of these things here, in it, I can clobber this line since we don't need it. In it, as part of starting up, it says, I'm going to initialize my state, my server state. And I'm setting these, my server consists of my state consists of two parameters that I'm calling top number and bottom number, initializing each to 0, and that's it. I'm done. I'm initialized, I'm up, I'm running. A very nice thing about Gen servers is while they're starting up, whatever said, please start up, blocks. This is not necessarily a good thing from a performance perspective. Say you're spawning 5,000 Gen servers, each of which takes 10 seconds to initialize. And say you're doing them sequentially. Please don't, but say you're doing them sequentially. You just shut down your system for an hour and a half because you can't do anything while everything comes up. That seems like a bad performance thing, but the reality is whenever possible, Erlang errs on the side of comprehension as compared to efficiency. They all basically go, I could make this faster, but this you will always understand and you will always know how this works. These lines, the things that say handle call, we won't bother with what the responses are. A call is essentially a synchronous request to a Gen server. So from any client, if you say something you want it to process and you want to get a response back, you send a call. And handle call is where the call gets handled. The things that you're sending it are, in one example, you're saying, hey, Gen server, please stop. In another case, you're saying, run something called get number. In the third case, you're saying, here's just a parameter. It's not get number, it's anything. New number is untyped. It could be any damn thing as far as we care. Remember, synchronous. What it means is if the Gen server is frozen, you don't get a response back. Well, you do after a timeout, but assume that the timeout is infinity. In that case, you're not going to get a response back. That's a good thing. Again, remember, efficiency over comprehension. It's like, if I know it's not up, if I know I'm not going to get a response back, I can tell somebody else to kill it. Things like that. Cast is for asynchronous events. I send a cast, I go away. Now the interesting thing here is calls, by definition, are guaranteed. Because if I don't get a response back, the guarantee failed. So it's guaranteed in the sense of the loop completed, therefore I knew that it worked. A cast is a spray and pray. I send the message. If the gen server is up, it gets it. If it doesn't, if it's not up, the message just got lost. It went to the wild. But sometimes you want to do that. I mean, a very good example is a watchdog timer. Fire the timer and then go away. If the thing is up, it receives the timer. If it isn't up, who cares? You did your job. You sent the watchdog timer down the pipe. Info is, for lack of a better word, the catch-all. By the way, this is a lie, but go with it. It's essentially the mechanism for saying, I got something, I have no idea what it is supposed to be, I'm going to run it here. And terminate is when you very explicitly want the gen server to shut down with prejudice, but not evilly. So yeah, it's like, I shot you, but I told you I was going to shoot you. So, you know, you kind of prefer that. Let's pretend you like that. The last one is easily the most overlooked one, and it's one that you almost certainly should not be using till the day you start using it, at which point you're like, oh my God, how could I ever have lived without this one? Code change is a thing that allows you to dynamically upgrade what your gen server is doing. Essentially what it does is you invoke this, you rewrite your module, a whole bunch of new functionality. What code change does is it says, take the old state and move it to the new state. And the whole point behind that is, if I just rewrote the module, added a bunch of extra functions, I don't care, it just works. However, if I rewrote the module and now instead of the two numbers out there, I have top number, bottom number, and middle number. I need to have some mechanism by which I can initialize the middle number. I might want to do something like the middle number is the average of the top number and the bottom number. I might want to do stuff to the system. That happens in the code change section out here. So, stupid examples here. I already went over the cast versus call, change return value, change store state. So, as a stupid example behind all of this, when you look back at the gen server, think about what a gen server actually is. This is your stupid, tiny, wee Erlang process. You can have hundreds of thousands, millions of these running on your little tiny node. Each one of these processes manages its own state, can get requests from clients, send responses back, can update its state based on the request that came in, can persist stuff to the system, can read stuff from the system, can act as a cache. It's basically your gaming front end. It's like every gaming system, every gaming server ever is this. Which is also a reason why, if you look at what's happening in the gaming biz, like 99.9% of all the startups, they write their stuff in Erlang right off the bat. And then eventually they end up moving to Django and Erlang. But there's a reason for that, because Erlang is spectacularly good at concurrency-oriented programming. It is the worst possible thing in the world when it comes to MVC-based stuff. So, you know, there we go. Okay, so if we, just to give you a bit of a handle on this thing, hey, what do you know? Dialyzer went through the system and it didn't find any errors with the thing, which I'm not surprised by the way, because there's nothing in here. This is like the simplest code ever. But if you took a look at what the code's actually doing at this, so a couple of really dumb examples on this one. if we, let's say we send the number, we send the function get number to the thing. Erlang colon whoops. Whoa, what did I just do? Oh, no, hold on. Get numbers. So what did I just do there? Get numbers versus get number. There's no get numbers here. The tricky part is there's a separate file I have out there which just has a bunch of it's a client, which if you look at these, all it's doing is saying the function get numbers is just running gen server colon call. It's just saying run a call against a thing, and that's a module that I'm running the this Erlang worker is the module that I'm running the function against, and the parameter that I sent down the pipe was get number, and it doesn't matter how many times I run it. All I'm doing is that. I'm just running get number, which basically says just send me back whatever your state was. Alternately, what I could do is say set number. And all set number does is, if you look at the code here, set number basically takes a number and flips bottom number to top number, sets the bottom number to the top number, and moves this in. So if I say here, oh, come on. If just rotating it through the pipe, that's all it's doing. It's trivial, it's easy, it just works, who cares? Like I said, this is really obvious stuff. Where life gets interesting though is supposing I say, you know what I want to do? I want to set it to 2 times the number. Actually, let's make it 20 times because we're feeling all like excited and fancy about it, which is a wee tiny font, but all I did there was I just ran it, load. I just reloaded the module, and if I set it, it set it to 20 times the thing. So, yep, so it's setting both. So this line is kind of interesting, whereas say L Erlang worker, that just means load the module Erlang worker. There's actually a whole bunch of trickery going on behind the scenes out there. Essentially the way it works is in Erlang in memory can keep 2 versions of a given module loaded at any given point in time. The moment the second version shows up, all new requests go to the new module. As soon as any existing request completes, the new requests go to the new module. So it's kind of like the existing module finishes processing whatever it's doing, and then the cutover immediately happens. That's the best way to think about this.
Can you clarify a question about that?
Mm-hmm.
So does a beam process, does it close after a request, or is Erlang managing them, terminating them now that it knows that there's 2 versions of
It's not actually a beam, it's just very specifically the bytecode for that particular module, for that particular file. That's the only thing that's loaded in there. So the beam is still running at all times. But the beam internally has the module signature for that given module, and it says, oh, hey, here's a new version of the same module. It looks at the call stacks for anything on the old module, and it says, there's nothing on the call stack, I'm just going to shit can it. If there is anything on the call stack, it waits for that to complete, and then shit cans it, and just moves the new one up to where the old one used to be. Again, determinism. It's like you know exactly what's going to happen.
there any notion of return value? What does that change this from a module to the,
Return value as in?
from a module?
From function to the module, yes, but the module itself is just a collection of functions. So think of the module as, it's poor terminology. Erlang has this awesome habit of using the file name to be the same as the module name, but the file is, when we say module, we interchangeably use it to mean both the file and the module.
But nobody's immediately affected by a module change.
Nothing, except for one scenario.
Otherwise, it'd be some propagation.
Correct. There is one scenario. Again, determinism. 2 versions in memory at any point in time. Say the call stack for the first one is still running. You update the module yet again, and you load it in. You're going to get a crap out. I mean, it will. I mean, all sorts of fun things can happen there. Usually the beam will crash. But that's because, again, it's like the running one and the new one. And there is no space for this thing.
That's where fault tolerance comes from.
But again, that's the whole determinism thing. And this actually is also where, and I'll get to this later, you have a concept of releases. So what happens is when you're initially coding, you do what I'm doing right here. Compile the code, load it, boom, we're happy, we move on. But at some point, when you're talking about production systems, you build releases, which are completely canned, self-contained environments, which contain the beam, have everything for it to run, for the Erlang system to run. And in releases, you have built-in upgrade paths and everything so that a previous release will automatically get upgraded to the new version of the release, and states will get upgraded, the code change version will get called in all the appropriate gen servers. It takes care of everything for you. Life is great in that sense. So there's a bunch more stuff you could do out here. However, I'll show you another one, which is, where did we go? Did I have this? So if you look at this one, I sent it the message stop. And what it did was that the rest of the line basically says, yeah, go ahead and stop when it stopped. The response that I'm sending is the process of the PID, the process ID of the gen server. Now it so happens that gen server is part of a supervision tree. Remember I started it up with start link? If I call this again, there's a different PID that just died. So every time that gen server died, the system just restarted it immediately saying, oh no, you're not supposed to die, you're supposed to start up all over again. Which is the perfect segue into supervisors. So when I'm talking about stuff like process trees and supervision trees and so on, there's a reason behind it, which is that Erlang OTP comes with all these built-in mechanisms for handling supervision trees. A basic supervisor tree is actually heinously entertaining, and by that I mean not at all entertaining. So the basic stuff is like before, you got the module name up top, we call it by what's it, I can't think of the word. Anyhow, we usually end it as _sup for supervisor. A bunch of random stuff that we don't care about. This is the entertaining thing. This is my exceedingly short form for when the supervisor gets started. Init usually says that's what happens when it gets started. It returns this incredibly long string of stuff which the system uses to figure out what it's supposed to do. So for example, this supervisor, this is the root supervisor or the main supervisor for the application that I built here for this demo. What it basically says is, I'm going to ignore the long string, don't worry about it, but there's a couple of things out here that are relevant. it says the name of the supervisor is Erlang underscore supervisor. We already know that. It's a module name, but I put it out there too. The thing it's supervising is the Erlang worker gen server. It's going to start that up. When this supervisor starts, it's going to start one of those up. The way it's going to start it is using something called a one-for-one process. This is where life gets really interesting. Picture a basic supervision tree. You got a parent, you got one child, which is what we have here. System starts up, it starts up the gen server that I showed you guys, and that's it, and we're happy and we're moving on. When the gen server dies, just restart it. If it dies, restart it again, and keep doing that ad nauseum. However, maybe I want to start up 10 gen servers. Remember I showed you that one example where the first gen server could start up a bunch of others? You wouldn't do that. You'd actually start them up here. Work with me on that. So let's say you got the basic one that I showed you. You have one which is responsible for initializing a database. You got one that's responsible for initializing a web server. And you got one that's responsible for filling the cache in the gen server that we started up from the database once it started up. So that's 4. The thing is, in this example that I just showed you, if we just killed the master process, we wiped out the cache. We need to refill that cache. So you need to tell the gen server that does the cache refilling that it needs to refill the cache. Oh, you know what? The database might have gotten screwed up too. So we should probably go back and reinitialize the database just to make sure we're all starting from a steady place. And the same with the web server. You don't know what the state of transient request was, so just wipe everything and start everything up from scratch. So what you could do is run something, the restart strategy, instead of one for one, if I said one for all, what it would do is when any process dies, kill everything and start everything up from scratch. Which sounds kind of harsh, but you do that and remember determinism, you know where things are. You can always start things back up. Take it a step further. I'm kind of past the determinism thing at this point. I know that if I do things in the sequence 1, 2, 3, 4, 5, then I only need to restart the things after the one that whichever one that died. So if 2 dies, restart 2, 3, 4, and 5, don't worry about 1. Because I start the database up to begin with, and that takes forever to start up. It's a pain. And usually the thing that dies is number 4, the cache warming thing. So just restart that one, and number 5, which is the actual cache. Right? That's the thing that says rest for 1. What it basically says is when any child dies, kill all the other childs that started after this child. And there's a last one, which is a tricky one, but remember it because eventually you will start using it if you go down this road. It's called simple one for one. Basically what that means is nothing starts up. What you do is you tell the supervisor, hey, start me a child, start another child. You usually use it for things like acceptors, web acceptors or processors or things along those lines. It's like, I don't know how many I'm going to need. I'm going to start up 10 to begin with. If I need another 10, I'll start up 10 more. Allows you to scale dynamically, things along those lines.
Is that like a thread pool?
Kind of, yeah. It's a good enough analogy, but think of it as a resizable thread pool. Or process pool. Better. So there's more. There are other ones that I won't get into. There's something called GenFSM, which is for finite state machines. I'm assuming everybody knows what a finite state machine is. The thing is, in particular, where it becomes useful in Erlang is when you're talking about protocols. Because when you're building any kind of a protocol, it's basically a finite state machine. This makes protocol handling, protocol translation, protocol setup, things along those lines, wire formatting, it's like a cakewalk. It's like the greatest thing in the world, ever. GenEvent is event handling. What do I mean by event handling? So if I when something happens, if I need to tell the database, the web server, the cache warmer, and the gen server, I need to tell each of them, hey, this thing happened. I can have my main process sit around, figure out how to tell every single one of them, or I can use a gen event, an event handler, and in that I basically register different dispatchers for each of those endpoints. For the database, do this. For the cache warmer, do that. And I can tell it, send the events out, send it in this order, do whatever. It takes care of everything for me. And it can also do things reliably, which is probably the most important part. So there's yet another level. I'm moving up the abstraction chain here. So there are the gen servers, gen FSM, supervisors, and so on. There's a thing called an application. This does not mean what you think it means. An application in Erlang is nothing but a simple bundle of functionality associated with a single root supervisor. Remember when I talked about localization, and I don't mean in the language sense, but I mean as in loose coupling. I want to take a bunch of functionality and want to keep it in one place and say, yeah, this thing deals with my system cache. This deals with all the web acceptors. This thing deals with my game state. This thing deals with user management, whatever, things along those lines. Each one of those is an application because I can very uniquely determine the functionality around it. And if it dies, I can restart it and not have to worry about anything else. That's maybe the best way to think about applications. If it craps out, you just restart it. Nothing about applications is that is maybe the best unit of horizontal scalability across nodes. So when you start up an application, just start up one application on each node that you got, whether that's 1, 10, 100, whatever your auto-scale group is. It just goes out that way. At the end of the day, an application, if you look at the code, is nothing but that. That line that I'm pointing at, that's your application right there. It's basically saying it's the root supervisor. The Erlang and that, if you all recall, is this line, which basically is the line saying, hey, start up my gen server. So it's my root supervisor that says, start up the gen server. That's all.
You used the term module earlier.
Mm-hmm.
How does module relate to application?
So interestingly enough, this is a module. This file is a module. Whenever I say modules, think file. Really, I mean, that's the, that's a lie, by the way, but it's a perfectly understandable lie, as in, it makes complete sense.
Okay, so that's how module relates to file.
Yes.
How does it relate to application?
An application is a collection of all the modules in that particular supervision tree. Also a bit of a lie, but much closer to the truth. Yeah. There's a couple of other things that go with an application, which include a file describing what's in this application. And it basically says, it's got a version number, it's got a description, and it's got a listing of the libraries that you're going to be using in this thing. Yeah. To be very precise, that file that I showed you is actually really important because what it tells you is here are the other applications that this application depends on, and when you start them up in this order.
Are you using OTP to bootstrap into this application module? Because I saw in that settings file, applications at top level.
So this is OTP. By definition, this is, it is. And when you start up an application, internally in Erlang, there is this incredibly awesome bootstrapping process that you just brought up that happens where the system starts itself up with a rootless root supervisor, I think is the best way to describe it. So your application is at the top level. If you go scan the code, and I recommend it, by the way, the code is it's actually eminently readable. It takes about a day and you're like, oh, now I get it. Actually, that's not a lie, by the way. It's one of the incredibly depressing things where Not the C code, by the way. I'm talking about the Erlang code. There's some C in there, yeah. But you read the Erlang code and you're like, that's it? Really? And the answer is, yeah, that is it. There is not much there. But the thing is, every single word in there is something important. You know, they've like polished and burnished, and they're like, yeah, we can remove the global on that line, which is a huge thing, but it took them like 3 years to get rid of the global in that one lookup.
So this, whenever I started working, so there's this kind of an app.earl file, and you have the file they just showed us, and then you have like these two other files that you talked about. Can you talk a little about the difference between all these files, especially the last two?
Right. So if you look at the files that I have on the list out here, let me take you through the ones that I already showed you guys. The Erlang worker, that is actually Gen server. We're good with that one. The Erlang supervisor, that is a file that was a supervisor that started up the Gen servers. So far, so good. Erlang.earl, that's the one that's just the client. It's just a placeholder for, instead of me having to type out Gen server : call Erlang worker number, I could just type Erlang : set number. And it's a shortcut. You don't need that line. It's just that why use, it makes code more readable, that's all. So there's that one. Erlang app is the application definition, and it basically just says how you start up your root supervisor. Everything else is completely irrelevant. Here's a dialyzer line for somebody, for you, which we actually don't need because the system knows that, but these two, actually these 4 lines, 12 through 17, are the definition of your application file. In almost all cases, you will find that this file, the _app file, has 6 lines in it, 8 lines in it. All the fun happens in your supervision trees. Okay, again, a bit of a lie. What happens is when you start things up, when you're putting in asynchronous startup things, this is where you put it. Classic example is I need to start up Amnesia, which is think of it as a database stroke cache, distributed database stroke cache that you use in Erlang and whatever. Not important. It takes a while to start up. Orchestrating that is one of those highly non-entertaining things. So you usually slap that in here and you say, start that, wait for it to finish, and then run that one line Erlang supervisor. So there'll be like about 10 or 15 lines of just stupid, horrible, sleep, wait, whatever kind of stuff. By the way, when I say stupid and horrible, I mean it's the kind of stuff that everybody's ashamed of, but everybody writes. You know, that.
Ironically, something that humans do all the time, right?
I know, go figure. Exactly. This file, is the file that I said describes what is in, think of it as a manifest for the application. I have to admit, 99 times out of 100, actually 100 times out of 100, I copy this from somewhere else and then delete stuff. Because that's what everybody does. It's like nobody remembers the format of this thing, everybody gets something wrong, and usually you have to go saying, what's its second argument in mod? I can't remember. And then you have to go look that up. And then you're like, oh yeah, duh, I knew that. Every time, like 2 days apart, you'll do that. So don't worry about that one. In the end, what ends up happening is everybody after a certain while just has canned application templates. They just copy it over and then just start filling in the blanks, which is the point. That's the point behind an abstraction. It's like sufficiently general, but still to the point that it takes care of everything that you need. Shoot.
So not an interview question, how that file was made.
Oh yeah, God, that'd be horrible. I would fail so fast. It'd be horrible.
I would say it would be scary if they could answer it.
So weirdly enough, one of my buddies, Juan Jose, Argentinian guy. For Erlang people, they probably know of him because he wrote the get op for Erlang, which everybody uses, and a couple other things. But anyhow, he remembers this stuff. He remembers the sequence of things in the supervisor incantation up front, which I probably could if you really pressed me on it, but please don't. But that kind of a thing. But some people do. Go figure. Anyhow, there's even more stuff in here when you get down to it. You've got releases. I mentioned this earlier. Releases are essentially about having packaged, standardized, fully self-contained incantations of Erlang and the application and your system. Not just that one application, but all of your applications bundled together, just run it. It makes AWS a joy to use because it's like, here's my release, just go, have a nice day. Distribution, not the strongest suite in Erlang. However, there's plenty of recipes out there that you can just use. Distribution is the part I mentioned earlier. Put it up on the autoscale group, it just runs. The entertaining part is then how do you get it to know the IP address of the other ones and the ELB and all that fun AWS-y stuff or Azure stuff if that's your whatever, but exactly. So back to what I was mentioning earlier, way back when, the 5 stages of Erlang. There's Erlang. After this, and even if not after this, you should be doing OTP. If you're not doing OTP, you should be doing OTP. In fact, really, there is no excuse. If you're writing Erlang, there's no excuse to not be writing OTP. It's kind of like saying, wow, I'm trying to think of, yeah, I'm going to write Python, but I'm not going to have any functions. It's like, seriously, I mean, you could, but why? That. There's a third stage, which I won't get into here, but it's common test. So when you're using Erlang, and I'll rip through this really quickly, when you're using Erlang OTP, when I say Erlang, I mean Erlang OTP. So just when anybody says Erlang, they mean Erlang OTP. Just be aware of that. There are 2 types of testing. There's eUnit, which is this classic standard assert unit testing stuff that you slap in. And there's common test, which very unjustly has a, oh my God, it's got a high learning curve, this is difficult to figure out, I'm not going to use it, whatever. The thing is, it isn't difficult to use. What you find, the key to using common test in Erlang, copy the file from somewhere else. Seriously. Copy it, delete stuff, just write your basic tests in there. It'll just work. As you're expanding stuff out, you'll start figuring out what all the different sections are, and it just does its own thing. I mean, it's kind of a hairy thing theoretically to figure out, but it's really not. And it makes testing, functional testing, a thing of beauty. It's like, once you figure out common test, you're like, oh my God, this is the greatest thing in the world. This is a life. This is truth. This is the way. I can't believe I wasn't using this before. And you go back and rewrite all your code again. You actually do, because you figure out that everything you wrote, remember you rewrote it already when you did OTP? You rewrite the damn thing again because you're like, man, that was just not testable, and it's a pain. Because what you end up doing is you write code which, as part of your deploy process, runs a comprehensive full coverage test suite, which actually gives you like 99 to 100% code coverage. It's unreal, and it's awesome. So you do that.
Do you end up with those circumstances where your code base is bigger than your source code? I mean, your test coverage is bigger?
Weirdly enough, no. Because, again, functional testing, it's like, usually what ends up happening is most everything you need to test what you're doing is already in the functions. So all you're doing is just feeding it a couple extra parameters, and it just goes in and does what it needs to do.
In your case, you need to write test coverage test.
Well, so here's where life gets interesting. But eventually, once you learn CT, You go down the road and you do get to that state. And you realize that this usually happens when you do one of two things. One is when you're talking about distributed systems and there's no answer there. Orchestration is just a pain. So ignore that one. The other one, which is much more common, is the moment you have more than about 20 test cases. Your file's yay big already. And usually you don't want your file longer than it can fit on a screen. I mean, you want to be able to just see stuff here, otherwise break it into a second file, whatever. The moment you do that, all of a sudden you got replicating files and you're like, which module does this go in? And you can't remember, and then you start cutting and pasting between them and it gets horrible. And then somebody tells you about this thing called proper or quick check, which is proper is the GPL version of a minified version of quick check that you can just use for free with Erlang. It just kind of works. Remember, GPL, very important. You can't use proper if it's production code unless your production code is GPL or you paid for proper. Or you don't tell them, which is between you and your maker. But you use proper, and essentially what this is property testing. So once you set it up for property testing, show of hands, property testing, some. Okay. For the non-property testing people here, think of it as, take a step back. In functional programming, lines are not just letters slammed together. Each line has a value. It's an expression. Every piece of code is an actual thing. So in property testing, you actually use and abuse that feature. So you look at a piece of code, and for example, I've got nothing here that's going to help on this one, but let's go with, oh, actually, you know what? Here, right here. Something equals something else, and that something gets used return a bit later. In property testing, what you do is you just say, you know what? There's no typing in any of this. There's no values. I'm going to just start injecting stuff into this and see what happens. Since there's no typing here, I'm going to inject a 0. Hey, there's a divide by 0 somewhere. Boom. Because those are usually the easy edge cases, right? 0. The next thing I'm going to inject is, oh, for argument's sake, how about this?
Yeah.
There's no typing. I'm going to send in an empty tuple. But wait, this is all supposed to be a number, and somewhere I add it to something else. Boom. I'll send in an arbitrarily long list. I'll send in, so it'll send in stuff, and depending upon how many runs you're willing to give it and how long you're willing to run it, it'll find these things in your code you did not know existed, and you will go back and rewrite your code. It is the most amazing thing.
How does this compare to generative testing?
Kind of the same thing.
Okay.
Yeah. Basically, think quick check for all the quick check people. But at the end of the day, that's what it does. And proper is, it takes your testing to like an all new level. And that's where your test cases all of a sudden go pfft and collapse all over again. Till you suddenly go proper crazy, and then you get expansion. And there's the last stage, which is something called state-M, which is basically state-based testing. So think of your ability to say, pretend your application is a finite state machine. By the way, this is an understandable lie, but it kind of works. Your app is a finite state machine. Your gen server, remember, had a state. You did something and went to a new state. With state-M, effectively what you're saying is when things happen from this state, where should they go? So instead of waiting to get your system up into a specific state, you can tell your system, start with this configuration, apply this set of things, you should end up here. It's definitely for what I will call advanced setups, but I don't mean stay away. I mean, you'll know when you need this. If you're doing, remember the bit about protocol work, you'll know when you need it. If you're talking about orchestration or coordination, you definitely need this. So, classic example, if you believe your system is capable of receiving unordered requests, and it'll reorder the requests based upon its knowledge of what's in the messages, you should be using Statum. By the way, if this problem doesn't mean anything to you, then don't worry about it. But for people for whom this means something, it's really important. It's like there's so much of the code that we tend to write tends to consist of assumptions we make about what's in the things that we're receiving. It's like, well, yeah, of course they're going to send us something with the body. Really? Why? Or the body's going to have an ID in it. It's going to have a unique ID in it that will not be repeated. Really? Why? Right? But there are these things that we assume and everybody knows, so we just do it and we never think about it, and those are the kind of places you should be using Statum. There's a whole bunch of other places too, but we'll stick with this one. And what it does for you is it goes out and it puts those assumptions to test for you. It's like the greatest thing ever.
So this is possibly a little bit facetious, but it sounds like when you're first developing an app, you don't actually necessarily know what it's going to do. So you don't know what state it's going to be in. So the advanced part of it is when you actually reach the point in your app when you can actually predict what it's going to do.
Absolutely true. So let me take that a step back. When I was referring to protocols, by the way, my point wasn't, oh, hey, we're going to implement a TCP/IP driver. Good luck. But I mean, that wasn't the point. The point was client server in the big sense. I've got let's stick with gaming because that's what I've been using here. I got a game client on my phone, and life is good. And the game client on my phone is sending things to the game server, which is one of like 57 web servers sitting out there receiving things. There is a protocol going on between this and that. There are specific messages that are being sent in specific orders, theoretically, asking it to do specific things. Theoretically, somewhere you should have a state transition diagram saying the world starts off as this. When you do something else, you move to this state. When you do something else, you move to that state. Hopefully you do, in that kind of a world. So that's kind of this, right off the bat you'd be using Statum in that, if that makes sense.
So it's still a little abstract to me because I have programming in Erlang. How many, generally in production, like how many gen servers do you end up instantiating? Like how many boxes, how many servers per box?
Okay, so trick question, and I'll give you a trick answer on that one. I've had systems in the past where we've had 5 boxes and 5 gen servers. I've had systems in the past where I've had about 5,000 boxen nodes and about 50,000 gen servers on those nodes, each node.
Per node?
Yeah.
So the overhead on a gen server is out there? Or?
So this is where life gets kind of interesting. Yes, there's overhead. So remember this section here where I said state? This is the state each gen server is carrying. So let's say a gen server has, think of it as a cache that allows you to process whatever. Say there's a 10 kilobyte cache in that thing. 50,000 of those is 500 megabytes, which is not bad. 5 million of those, now we're talking real memory. Anybody heard of a company called Klarna? Klarna is this huge payment processor in Sweden. They gone and screwed up early on in their design phase, and they didn't really build something for distribution. So they ended up with processes with lots of cache and servers with lots of gen servers, to the point where they're running machines with multi-terabytes of RAM, because that's just the way you need to do it. There's no way around it. By the way, multi-terabytes not as in 1 or 2, but as in lots. I know, it's awesome. Now the trick here is okay, I won't get into this here, but one of the things you can do with pretty much all the gen servers, gen FSM, gen event, everything, is you can get them to do something called hibernate. Hibernating a gen server is, you tell this gen server, hey, hibernate yourself. What it does is it discards its call stack. What that means is it never returns. When you say hibernate, it's like it happened. You just, anything else that was doing something with it is gone. It discards a call stack, discards everything, packs itself down to basically its state, its current running state, plus, last time I remember looking, it's about 300 bytes, and vanishes from the system. So at that point, if you don't have that much state, you actually could have millions of gen servers. When is this relevant? Let's say each of these gen servers is a user in your system. Then what you do is you basically tell this thing, hey, if you haven't been accessed in 24 hours, go hibernate. Pfft, gone. Actually, the smart thing to do is, what's the prime number? 23? Hibernate in 23 hours. People know the prime number rule? When you're doing anything with periodicity, use prime numbers. Don't use 10, use 11. Don't use 100, use 97, 101, 103. Because when bad things are happening, you'll be able to extract them from the signal from the noise. Yeah, exactly. And yes, hence 23. Say what?
If you learn anything else tonight, that's the one thing.
Oh God! So just so you all know, I learned this in power systems class in my electrical engineering course back in college, way the heck back when. So, I mean, people have known about this forever, but then it never goes anywhere.
Okay, so
Go ahead.
question is,
No.
What are your supervisor trees sort of like? What are they shaped like? What do you make sense to write them? Do you end up with like?
It is completely application specific. So examples, for example, the user, let's just make up a generic system. You have something that spawns users. So when a new user gets created, there's a simple one-for-one supervisor somewhere that's the user supervisor. And every time a user gets created, it creates another gen server for that user. Great. Let's see, what else do we have? We got customers who have users. So I got a customer supervisor. We're selling cats. Okay. So we're selling cats. We got a cat supervisor. You get the point. It's so problem dependent. Not to be too trite about this, but one of the really good things about this is your abstraction can really mirror the real world, because the point at which you need to start worrying about optimizing and efficiency and so on is so far down the pipe, it just doesn't matter.
So you were kind of toward the end of talking about hibernate, but
Mhm.
you didn't quite. So when the process hibernates and it's down to 300 bytes plus the state, what happens to
Just
that
call it.
state?
It'll unhibernate. Yeah, immediately. So the thing with hibernate is it's resource intensive to hibernate something. Resource intensive is a very relative term here, as in it's not at all resource intensive, but when you're hibernating 5 million things, then it kind of adds up.
It's about the same as doing garbage collection.
That's basically what it is. In fact, it's exactly that. There's a garbage collection cycle, and then whatever, which I'll get to that in just a moment. But basically, what you do is it hibernates, and if you immediately invoke it, it's going to come right back and say, dude, what'd you do that to me for? Yeah.
How do the gen servers use credits? Erlang,
No connection whatsoever. So basically, think of it as the beam. Okay, this is, again, understandable line moment, but we'll go with this. Think of Erlang as essentially having a scheduler for every core that you're running on your system. Right, that's your beam thread. What the scheduler basically does is, this is another Erlang moment here. Every single thing that happens in Erlang has a count associated with it, a count of something called, for some absolutely ludicrous reason, reductions. they could call them Fetzer valves for all the difference it made. But basically, reduction is think of it as an efficiency count. What a scheduler does is it gives each process a certain number of reductions before it kicks it out and moves on to the next process. And yes, this is an understandable lie. So for everybody who knows something about this, they're like, wait, that's not exactly what happens. It's like, yeah, good enough. But that's broadly what happens. A scheduler is 1 to a core. So if you got a 16-core CPU or a machine, then you got 16 schedulers. Theoretically, if you're running 16 processes in the system, it's hammering its way through perfectly. The reality is that's not going to happen, because this is where the nature of Erlang fights against itself. Erlang is really, really, really good at communication-oriented stuff, because you spend so much time in communication that the actual efficiency of the process itself doesn't matter. But if you want to do something like implement FFmpeg in Erlang, don't do that. So that's kind of the other side to this.
So gen servers go arbitrarily across the processes, they do not pick one, you can't control that.
Right, because there is no such thing as a process in that sense. It's the scheduler. Scheduler A runs it for a while, drops it, scheduler B picks it up, drops it. There's just a...
There's a pool for all the schedulers to pick up.
Kinda. Now that's also actually not totally accurate, but yes, good enough. Yeah, they made a bunch of changes around R17, which have individual scoreboards for each scheduler, and then master scoreboards, and things move up and down, and it's that's why I said total understandable lie. It's kind of like, you know what it's like? Compiler theory. You know, you learn compiler theory, like, yeah, I totally understand this. Then you look at what it's doing, and you're like, this has nothing to do with what I learned.
Right.
That. Bingo.
Can you explain the FFmpeg? It's a very low communication.
It's interpreted. It's an interpreted language. So if you want machine speed or machine sympathy, you're not getting it with Erlang. You're getting, it's just stuff happening up here. So.
You seem to imply that the communication overhead is significant enough that you don't care about the process efficiency.
Basically, yeah.
It makes sense.
Right.
Sense. But how does that relate to FFmpeg?
No, just purely because if you want to do something that's just doing a massive amount of discrete cosine transforms and whatever, and yeah, exactly, then just don't go there. Yeah.
Is garbage collection stop the world and everything?
Ah, right, garbage collection. Right, so garbage collection in Erlang is a topic all unto itself, but the extremely short version here is it's a 2-pass garbage collector. Essentially what happens is in Erlang, everything, wow, what's a simple way to put this? You know what, let me put it this way. In Erlang, whenever a process dies, anything that it was part of it just gets immediately freed up. So that's one wonderful thing. There's a lot, because of the immutable nature of a lot of what's happening in of functional programming, cleaning up things that you're using is also incredibly trivial and incredibly easy. Because of that, and the third thing is because a lot of the design decisions of Erlang involve near real-time processing. You want to build near real-time systems in Erlang, so you don't want things which are stop the world. Definitely don't. So what you basically end up with is kind of like a 2-pass garbage collection thing. It's something, and when something gets used, it gets put on phase 1, for lack of a better word, and if the reference count goes to 0, you just chuck it. If the reference count doesn't go to 0, after a couple of passes of the GC, it gets moved to phase 2, and it sits around phase 2 where there's a deeper garbage collection cycle.
Generational?
Generational, yes. Now the thing about this is, again, garbage collection is one of those things where, very broadly speaking, there are 2 approaches. Approach number 1 is the actually no, I'm doing this at a meta level. Deterministic, but non-efficient. So what Erlang basically does, it says, this is the way things are going to work. You may not like it, but this is the way it's going to work. And if you really, really, really want to do something in your gen server, you're afraid that it's not getting collected, you have like an invocation count that you slap in. Every time somebody comes into my gen server, increase a count in my state. Remember, your state is keeping track of it. When that count hits 5,000, garbage collect myself. You can call garbage collect on self, and it'll garbage collect itself and clean itself up. And that's a very common way in which people forcibly and deterministically clean themselves up. Because this gen server, this process, knows when it is free and when it is not, because it is in control of its own destiny. The other mechanism that you have in general with garbage collection is your bells and whistles. Keep adding more bells, keep adding more whistles, and essentially get it to the point where if you know everything there's to know about everything, you can probably get just the right collection of knobs and dials so that the JVM doesn't kill you the next time it's running. It's a JVM approach to existence, basically. You know, how many flags are there for the JVM garbage collector? Infinity, or some near order of infinity. You know, Cantor probably knows. But anyhow.
Erlang doesn't run on JVM, right?
Say again?
Erlang doesn't run on JVM.
No, it doesn't. It's the beam. So the reality behind now that I said all of this, if you are doing production stuff, you will at some point hit garbage collection issues in Erlang. All I have to say about this is they tend to be much more rare. They do tend to be rarely esoteric. They tend to be much more, there's a common set of problems that people run into over and over again. Like everybody who's going down the I'm writing production systems will hit the problem. You use the Googles and you get the answer. I'll give you one right now. Binaries, big binaries in Erlang. Whenever you do anything, we chop it up to little tiny snippets to do something with it. You got a big binary, like a file that's a gigabyte long, and you don't want that entire gigabyte of the binary. You just want 10 kilobytes at a time. So you chopped it up into 1 gigabyte divided by 10, so 100,000 10K snippets. Awesome, and you're moving it around the system. What you don't realize is, as long as there's even one of those 10K snippets sitting somewhere in the system, that 1 gigabyte file is still going to sit around. Because the snippets are just references into that. So that's the phase one of going, aha, I was dumb, you clean that one. Phase two, which most people don't get to because they never get to it, but you'll eventually figure out, is as long as any process that has ever touched any one of those snippets is still alive, it will not get garbage collected. Any process that has touched it. Which was the point behind the garbage collection thing that I mentioned out there, where it's like a really obscure and esoteric thing, and for most of you it's never going to be an issue and you don't need to worry about it. But if it does become an issue, remember I told you so.
Okay, I think that's a good time to wrap up.
Wow.
Will you be joining us at the bar?
Sure.
Awesome. So if you have any more questions, please come out to flight 151, where we'll hang out and you can ask and learn so much more about Erlang, OTP,
Or prime numbers, as it turned out. Yeah. Cool. Thanks, folks.
And remember, the close talk. Ooh, that was.
Ooh, yes.
Uh-oh.